Hi, my name is Mel, and I'm going to be talking today about plesiosaurs because I saw a video on YouTube about some person saying that plesiosaurs were impossible or it was it's evolution's mistake or something. I've got no idea what he's talking about, and I'm not an expert, not a biologist. I do cybersecurity, I do tech, I do IT. I'm very far from being any expert, so I've just looked up scientific papers, and this is what I have found. So, plesiosaurs were a highly successful order, Plesiosauria, of the Mesozoic marine reptiles that ruled the oceans for over 130 million years, which is longer than humans have been around, quite honestly, from the late Triassic until their extinction at the end of the Cretaceous period. Though frequently grouped with dinosaurs in popular culture, they belong apparently to a distinct lineage of secondary aquatic reptiles. They are famous for their unique underwater flight locomotion using four massive flippers and are widely known as the scientific inspiration behind the totally mythical Loch Ness Monster. So, what are their evolutionary body plans? The order Plesiosauria traditionally splits into two distinct non-taxonomic morphological types based on hunting adaptations. Plesiosauromorphs features an incredibly long stiff neck containing maybe up to 76 vertebrae, small head and a streamlined body. They were ambush or stealth predators that targeted small fish and cephalopods. Plesiosaurids or plesiosauromorphs, and I hope I'm saying this correct, Pileo. Anyway, built with a short, robust neck and a massive skull with powerful jaw mechanics, they evolved as apex predators capable of eating large marine reptiles. So, some of the key paleobiological discoveries that I could find, and look, I tried my best. Hopefully, this is accurate. If it's not, paste a comment under the video and give me some peer-reviewed science paper to look at so I can. I've looked at some peer-reviewed papers that I could. I can't pay to access a lot of them, so I've had to try and get, some general stuff. So hydrodynamic skin. Recent soft tissue analysis of well-preserved Jurassic specimen from Germany revealed a smooth, scaleless skin on the tail and small subtriangular scales on the flippers to assist with underwater traction and propulsion. Live birth. There appears to be fossil evidence of a pregnant adult skeleton confirms that plesiosaurs were viviparous or giving birth to live young at sea and likely engaged in high maternal care, much like what modern whales and dinosaurs. I mean, modern whales and dolphins, sorry. My brain's fritzing today. Despite spending their entire lives in the open ocean, they lacked gills and were obligate air breathers that routinely surfaced for oxygen. So, plesiosaurs managed to survive multiple minor extinction events across the Jurassic and Cretaceous periods before being completely wiped out 66 million years ago. They disappeared during the KPG Cretaceous Paleogene mass extinction event, triggered by a massive asteroid impact that simultaneously eliminated the non-avian dinosaurs. Of course, the avian dinosaurs are birds. Some plesiosaurs had relatively long necks, the longest of any animal relative to body size. But to claim they were an evolutionary mistake or impossible is a myth that is used as a dramatic hook in media. In reality, this body plan seems to have been highly successful adaptation that allowed them to dominate the oceans for over 130 years. And yes, I stutter and mispronounce word, and I have autism. Just deal with it. I'm sorry. If you don't like it, do your own videos, all right? Just, look, yeah, I do, but, like, doesn't mean I don't have something to say. You don't have to listen. If it bothers you, I'm sorry. There's nothing I can do about it. The The claim that their necks were impossible usually stems from outdated artwork showing them holding their heads high out of water like swans. What the reality is that biomechanics apparently showed that their necks were likely too heavy to fit above the surface without collapsing their airways or causing blood pressure issues. Instead, they held them straight forward underwater, and as I said, merging to get air every so often. So there's also a myth of flexibility. Popular media often depicts them as coiling their necks like snakes. Fossil analysts apparently reveals that their neck vertebrae had interlocking projections, making the neck relatively stiff rather than flexible. They likely moved in broad sweeping arcs rather than tight coils. Were they a evolutionary mistake? So far from being a mistake, the long necks appear to have been a special tool that provided distinct survival advantages. So it provided stealth hunting. The small head could sneak into a school of fish long before the massive, disturbing body arrived, preventing prey from panicking. Ambush range. It allowed them to sweep a large volume of water for food without needing to constantly paddle their large, heavy bodies, conserving energy. Benefic feeding. There are some theories that suggest it helped them reach down to scoop prey off the seafloor or tight reef crevices. Just how long were their necks? The ultra-long description is only mostly accurate for a specific family called Plesiosaurs, and I am mispronouncing all these scientific names, and I apologise. You can look this stuff up yourself. Plesiosaurus apparently had a neck that might have reached up to 7.3 meters long, roughly half its total body length. It had, 72 vertebrae, neck vertebrae. For comparison, humans and giraffes both only have 7. Albertonicetes, the current record holder, with a neck containing 76 distinct vertebrae extending 7 meters. So, the ultra-long only appeared to be a specific family. To say that Plesiosaurs was evolution's strangest mistake, which apparently this YouTuber claims, relies on sensationalism, outdated science to generate clicks, in my opinion anyway. Calling a wildly successful group of animals an evolutionary mistake ignores a massive amount of paleontological evidence. So what does this particular, I'm not going to say this video is, I mean, I don't think that's fair. But what do this person claim? The survival metric. Apparently the video claims that the ultra long neck was a design flaw that hindered the animal, framing it as an evolutionary failed experiment. So what does science seem to show? That evolution measures success over survival over time. Plesiosaurs first appeared in the late Triassic and thrived until the end of the Cretaceous. They ruled the global oceans for over 130 million years. For comparison, modern humans, Homo sapiens, seem to have only been around for about 300,000 years. An animal body plan cannot be a mistake if it dominates the planet for 130 million years. The hydrodynamic drag myth. So the video apparently claims that swimming with a neck that long would create too much drag, making the plesiosaur clumsy, slow, and aerodynamically impossible. So what does science seem to point to? Computer simulations and biomechanical modeling prove that long-necked plesiosaurs experience relatively low drag, provided they swim at slow, steady speeds. They apparently were not built to speed through the water like modern tuna. They were slow cruising stealth hunters. Furthermore, there appears to be recent fossil evidence proves their necks were incredibly thick, heavy muscled, and streamlined with soft tissue rather than the thick, spindly, often shown in animations. So there's in this video, there's a the video that I'm sort of critiquing. There's a misunderstanding of the stiff neck abduction. So the video appears to claim that the neck was highly inefficient because it couldn't flex or bend dynamically like a snake. So science apparently shows that the stiffness of the neck was actually a critical feature, not a bug. If the neck had been highly flexible, the lateral force of water pushing against it with the plesiosaur tried to strike prey would have bent the neck backwards, causing the animal to miss. The interlocking vertebrae acted like a rigid beam. They allowed the plesiosaur to drive its head straight forward with perfect, accuracy to snare fish. The stealth and strike advantage. So the video that I'm sort of critiquing claims that a massive body with a tiny head makes no sense for an apex marine creature. So what does science look at? The exact layout gave them a unique hunting niche. Water transmits pressure waves which fish sends to detect approaching predators. Because the plesiosaur's massive bodies was relatively, some distance from its tiny head, fish could not feel the pressure wave of the body approaching till the jaws are already snapping shut around them. The long neck separated the detector, the prey, from the threat signature, the large torso. Why they went extinct. So the video appears to claim that their bizarre anatomy ultimately led to their downfall. What just science seems to point to, the plesiosaurs did not die out because of their long necks. They were wiped out by a 66 million year old asteroid impact, the KPG extinction event. This catastrophic event blocked out the sun, collapsed global marine food chains, and killed off 75% of all life on Earth, including the non-avian dinosaurs on land and mosasaurs in the seas. They were perfectly adapted to their environment right up until the planet faced basically probably what amounted to a nuclear winter. So the locomotion, the four-winged underwater flight, plesiosaurs possess a locomotory system that seems to be unique in vertebrate history. While modern sea turtles use their front flippers for power and back flippers for steering, plesiosaurs appear to have used all four limbs for propulsion. So hydrodynamic robotic modeling and computer simulations appear to show that they used a method called subaqueous flight, similar to modern penguins and sea lions. They flap their massive flippers in tight figure-8 crescent-shaped motion, apparently, according to the simulations anyway, generating thrust on both the upstroke and the downstroke. Gate control. The forelimbs and the hind limbs did not move randomly. They used what appears to be from the robotic modeling and computer simulations have an alternating gate or a synchronized pitch system. The front flippers creating a vortex of water that move backwards. The rear flippers then slice through the moving vortex, catching recycled kinetic energy to boost efficiency. The skeleton, to support the massive muscles required for this, their underbellies probably evolved into a rigid plate-like structure made of fused bones, the plastron, and tightly knit belly ribs, gastralia. So there's also the respiratory physiology and the dead space paradox. And again, I'm reading this from science sites and peer-reviewed papers that I can access. And what I know is just from what they're saying. I urge you to check this out. You don't have to believe me. In fact, I encourage you to go out and look for yourself. Get good peer-reviewed scientific information. Don't take my word for it or any other person, what does peer-reviewed science say? And that's what you should be looking at, all right? But I'm just trying to present what I seem to have found, and that's why I'm not claiming this is absolutely what happened or what they were like, because I'm only going from and I don't have access to all the peer-reviewed papers because they're behind a paywall, which I can't afford to do. So look, this is not me claiming. I just think I'm critiquing a particular video that seems to have fallen into making some critical errors, let's just say, from what I could find. So breathing through a 7-meter neck presents some atomical atom, like body plan hurdle known as tracheal dead space. When an animal exhales, some stale air remains trapped in the windpipe. If the neck is too long, the animal will just inhale that same carbon dioxide rich air on the next breath. So what's the solution? Histological studies of fossilized respiratory cartilages suggested that plesiosaurs might have had an incredibly wide trachea to lower resistance. The bellow systems, apparently, they do not breathe like us humans, using just the diaphragm. They used gastrolal breathing by contracting the muscles surrounding their belly ribs and pelvic plates that could physically expand and compress their entire torso like a giant bellows. This forced, a large volume of air through the windpipe in a single high-pressure breath, mostly clearing at the stale air. So look, they did have, evolution changes that managed this. Buoyancy, control, and gastrolith. Okay, because they were air breathers with relatively large lungs, plesiosaurs faced a constant battle against floating too high in the water column. Litho-breaking, stomach stones. Apparently, skeleton excavations routinely discover clusters of smooth, round stones called gastroliths inside their rib cages. Dual purpose. Scientists originally thought these were swallowed strictly to help grind up food in the stomach, like modern birds. However, some modern volume and mass analysis show they acted primarily probably as ballast. By swallowing specific amounts of stones, plesiosaurs could, um, uh, tune up their natural or their neutral buoyancy, allowing them to cruise effortlessly at targeted depths without burning energy to stay submerged. So reproduction, which is called marine, and I'm going to mispronounce this, viviparity. For decades, scientists debated with whether plesiosaur somehow got onto beaches to lay eggs like sea turtles. But in 2011, there was a spectacular fossil of a polycotylus that provided some proof. Live birth. The fossil contained a large mature adult with embryonic skeleton preserved inside its pelvic cavity. This seemed to confirm that they gave birth to live young at sea. All right. K strategy reproductive investment. Unlike sea turtles, which lay hundreds of tiny eggs and then just abandon them, which is not a moral judgment, but that's how they've evolved to do it. Plesiosaurs gave birth to a single baby that could be up to 40% of the mother's total length. Poor mother. I mean, that sounds like a big baby. Maternal care. This energy investment might mean that plesiosaurs were cave strategists like whales, elephants, and humans. They likely lived in social pods and nurtured their young, protecting them from apex predators while they grew. Thermoregulation, they were warm-blooded. Oxygen isotope analysis of teeth in an animal has solved the mystery of how plesiosaurs survived in cold polar waters, as fossils have been found in high latitude zones like Antarctica. Endothermy. It appears that plesiosaurs were endothermic, warm-blooded like we are. They maintain high internal body temperatures, roughly, apparently, 35 C to 39 degrees C, that's Celsius, independent of the water around them. High metabolism. This metabolic rate fueled their constant active swimming, the growth rates, and the energy required to gastrointestinally support a single embryo. Diet and ecosystem niches. By looking at the fossilized stomach contents, colites, and tooth wear marks, paleontologists seem to have mapped out the Mesozoic marine food web. Plesiosaurids, which are short-necked apex predators, seem to possess relatively large skull structures and conical teeth with deep roots attached to withstand crushing forces. They hunted other marine reptiles, large fish, and ammonites. So the plesiosauromorphs, long-necked variants, seem to possess thin needle-like teeth that lock together like a cage when the mouth closes. This is highly specialized trap for slippery, soft-bodied prey like small fish, squid, and belemnites. And I've totally mucked that up. Yeah, plesiosaurs lived entirely in the water. So what did they appear to evolve from? Plesiosaurs most likely evolved from terrestrial land-dwelling reptiles that walked on four legs. During the Permian Triassic mass extinction, which was about 252 million years ago, life on land was fairly devastated. The oceans, however, were wide open and filled with food. Over millions of years, several independent groups of land reptiles returned to the water because there was food there and they could survive better, And it was a slow process. They didn't just all do it one day and go, hey, yippee. Mirroring how the land ancestors of modern whales and dolphins did so much later. The ancestor group, plesiosaurs, belong to a broader group of marine reptiles called Saurophytologia, the transition animals. Their earliest ancestors appear to have been small lizard-like coastal reptiles like Plesiosaurus and Nothosaurus. These early Asics that lived during the Triassic had webbed feet and still crawled on their beaches to rest or lay eggs. Over time, their legs flattened into rigid paddles, their joints locked to withstand water pressure, and they lost the ability to survive on land, becoming fully aquatic. So there are no living descendants of plesiosaurs. There is a common misconception that they might have evolved into sea turtles, whales, or Loch Ness monsters. Sea turtles are an entirely different reptile lineage that evolved independently from a separate land ancestor. Whales are mammals, not reptiles, and the Loch Ness Monster doesn't exist. The resemblance to plesiosaurs, flippers, live births, and more blood is a result of what's called convergent evolution, the process where unrelated animals develop similar traits because they adapt to the same environment. So when the plesiosaurs died out and when the asteroid hit Earth, their branch on the evolutionary tree of life stopped completely. So obviously that was, when the asteroid hit. And that's sort of like what I could find about plesiosaurs. And as I said, I urge you to look this up yourself. And I don't, like, if you find peer-reviewed science that's not from creationists or intelligent design crap that says differently, please post the links in the chat or tell me where you got it from. Not interested in creationist ID bullshit, because it's bullshit. This is just what I could find. As I said, I can't get access to all the material, so please do not take my word for it. Go and look at this stuff yourself. And, let's support science so that everyone can get, science and scientists, so everyone can get access to papers and stuff like that, because this sort of information, misinformation, look, the person who made this video, I don't know if they knew any better or they just, what research they did that showed this, but from what I could tell, the person that made this video appears to have fallen into some very common misconceptions that it took me like about an hour of researching on the internet to find differently. So, I mean, look, I don't know, and I'm not going to bag them because everyone make mistakes. I make them all the time, and everyone can be wrong. I'm wrong frequently. So I'm just saying is, do your own research, and I don't just mean look at stupid YouTube videos, and look, I'm going to be honest, this is just a stupid YouTube video, but look into this stuff yourself. Thank you.